Your support policy changed yesterday. Refund exceptions now require live account state. But this morning, an agent retrieves a memory from last month. That memory says policy version 2 allowed the refund. The live API says policy version 4 does not. The agent trusts the retrieved memory because it looks relevant, answers the customer from the stale rule, and then writes a new summary back into long-term memory. Issue resolved under refund policy. Now the next request does not just retrieve old state. It retrieves a fresh-looking memory created from the mistake. Your agent is not just retrieving stale memory. It is learning from it, acting on it, and writing the mistake back as fresh context. Long-term memory feels like storage until the agent can write to it. Then it becomes a loop. You ingest an event, you retrieve related memory. The model reasons over that context. It calls a tool. It summarizes what happened. Then it writes the summary back for the future. Every step can be reasonable alone. But the loop is now a production boundary. If bad context enters before reasoning, the writeback step can convert a stale premise into new evidence. That is why memory corruption is more dangerous than a single bad answer. Memory decays in boring ways. An embedding model changes, and old vectors still score well enough to win. A business rule changes, but the memory never records the source policy version. An entity is deleted, merged, or transferred to another tenant. A tool result was correct when it was stored, then the outside system changed. None of those are mystical failures. They are versioning failures. The dangerous part is that vector search hides them behind relevance. The fragment looks related, the source text sounds plausible, the score is high. But its truth state has expired. The trace you want is simple. Agent request, Gen AI, retrieval tool live state, Gen AI, chat memory write. Use OpenTelemetry's Gen AI conventions where they fit. Record retrieval documents with their IDs and scores. Then add the application-specific provenance. RAG memory written at, RAG memory embedding version, RAG memory source state version, RAG retrieval score, and RAG memory truth state. That last field is your result from checking retrieved memory against live state. The point is that the whole loop becomes inspectable in one trace. When the contradiction score fires, do not wipe the vector store. That is panic, not operations. Quarantine the fragments that contradicted live state. Block writeback for this request, because the agent is about to turn a bad premise into future evidence. Mark the memory family for selective reindex. Then rerun the request with quarantined memory removed and live state promoted. This is targeted amnesia. The system forgets the contaminated path, not the whole customer history. Before you close this tab, one question. When your agent retrieves a memory that contradicts live state, which do you ship first? Wipe the whole vector store, or quarantine the fragment and reindex only that family? Drop your answer in the comments. If this made the feedback loop visible, subscribe for the next observability breakdown.